We start with a not-so-small portfolio of 5,000 trades containing IR, FX swaps and options. And we compute a one-year value at risk with default parameters. It is essential, when calculating VaR or expected shortfall, to have all market data correct. Indeed, an outlier market data can cause the corresponding scenario to become among the worst ones and impact the final result. This can be done in a few clicks. Click on Check Market Data. It opens a window which displays all market data out of date. Then, clicking in Contribute History will make sure they are updated, using market data providers such as Bloomberg or Refinitiv. After 1 minute and 30 seconds, we cut 1 minute on the video. The 5,600 missing market data have been updated. The VaR can now be calculated accurately. To calculate a historical VaR, 2 steps are required. First, convert a past scenario into an equivalent as-of-date scenario. This is done very accurately by translating exactly the forwards. Then, amend time series of risk factors by techniques such as volatility scaling, and compute the P&L. Many options are available for fine-tuning, for instance, volatility scaling with burning period and volatility floor. Calculation confidence level different than actual confidence level, to allow a fat tail extrapolation. These options allow us to fit CCP methodologies when calculating initial margin. We can access the P&L time series computed in each scenario, and sort it by P&L. We can also optimize significantly the calculations. We compute sensitivities. This is extremely fast thanks to auto difference. Then the risk-explained P&L is used to identify the worst scenarios and calculate actual P&L only on them. We can compare actual P&L versus risk-explained P&L on the worst scenarios. A tolerance on the number of scenarios is applied to make sure the worst ones are always correctly predicted. By default, the value at risk is a single number applying to the whole portfolio. This is what we observe if we try to display results by netting set, for instance. What if we want to see a breakdown by deal or netting set? This is the concept of marginal allocation. We just need to change granularity equal to netting set and recompute aggregates. Not P&L scenario results which are stored by deal. Using the pivot table, we see that breakdown by deal is not calculated. For that purpose, we just need to set granularity equals to deal and recompute. In the same spirit as marginal allocation, we can also compute a VaR breakdown by sensitivities. This is done in one click thanks to the Open Risk Explained View button. Here, measure column represents the VaR, risk the sensitivity. We note that the VaR calculated in this view, 155 millions, is not equal to the VaR calculated before, 159 millions. That's because a first-order risk-explained P&L is computed. The results look summarized, but we can get access to the full granularity by double-clicking on any number. For instance, here is delta on Sonia curve and its contribution to VaR. Finally, we can match VAR result with its risk-explained counterpart by ticking the option Use Risk-Explained P&L in the main view. Now, the two numbers are matching exactly. As already stated, getting the right market data is key to have an accurate value at risk. In this example, we entered a wrong market data on purpose to see if we are able to detect it. Looking at P&L scenarios, we see that P&L as of 28th of September is massive and dubious. We're going to do a risk explanation at that date to check the relevance of the P&L. We play with the pivot table to find the main contributors to the P&L. We find a massive P&L on GBPOIS Delta, CRZ name for Sonia. Drill downing by double-clicking, we find a massive move on the 12-year bucket explaining itself most of the P&L. Going back to the market data, we find that the 12-year swap rate is indeed wrong. Its correct value is 4.093%. Saving it and recalculating the VAR will give the right result.